Okay, so our project was on car price prediction as well by me, Armand, and Byron. And so the first step in our process was to clean our data set, and we did so by removing unnecessary columns, vectorizing categorical columns by using dictionaries and mapping certain indexes to certain words, and also by normalizing the data. Once we did that, we moved on to choosing our model. And in our case, since we had multiple predictors that all correlated with the price of the car, we decided it was beneficial to use linear regression. But since we had multiple predictors, we decided to use a type of regression known as an RFE or recursive feature elimination regression. And finally, to test how well our model did, we used mean absolute error, found the accuracy of our predictions, and also used the R-squared test. So for data visualization, here's the original head of the data compared to the edited and processed data. We can see that the ID column has been dropped since it had no real value and would have biased the model to memorize the IDs to predict price rather than train on other factors. In addition, the levy column had been dropped due to large gaps in the data, and also columns such as mileage have been modified so that rather than containing strings and integers, they only contain strings or integers. And finally, all the categorical columns have been vectorized. So as I stated before, we have multiple predictors for our price, leading to a linear regression using multiple factors, and the formula below illustrates the equation necessary to predict a dependent variable, where it contains all the slope coefficients for each predictor along with the intercept for the general regression. However, I also mentioned that we use an RFE, which is a recursive feature elimination linear regression model. And what this does is predict price using each of the features one by one and selecting the best combination of features to use to predict the price while eliminating the rest. And thus it recursively eliminates unnecessary features. And the picture on the right also shows how this works.
So as we already said, to test our accuracy, we used the R-squared and mean absolute percentage error. So our R-squared value was 0.215 and our mean absolute percentage error was around 16. And we also had an F statistic of 167. And the method we used was the least squares method, which works by reducing the sum of the squares of the residuals resulting from each individual equation. And the method of least squares is commonly used in regression analysis to estimate the solution for overdetermined systems, and it's also often used in data fitting.
Conclusions, we use a linear regression model and the R-squared value is 0.215, and our mean absolute value is 15.99. The accuracy of our model is not that good. We can use neural networks in the future to increase accuracy. And we chose car price predicting datasets and used linear regression model. We evaluated mean absolute value and R-squared value, but the accuracy not as high as we expected. Maybe we should try the other methods to make it better. Also, during the project, we split our work and increased our efficiency remarkably.